Okay, so what happens if a greatest common factor is not the case? Well, I'm going to teach you this method called the slide and divide method, which I do think you will end up liking at the end. The first time you see it, you may be like, okay, I'm not sure how I feel about this, but I do think I can convince you to like it. But we use this method that I'm going to teach you when the leading coefficient is not 1, so what we've been doing, and the greatest common factor is not enough, or the greatest common factor doesn't work. So I will show you a case of both of these. So the greatest common factor not working or is not enough. So for instance, we're going to start with this example. I see 2x squared minus 5x plus 12. I notice that the first term does not have a 1. It has a 2. So I need to either factor out a greatest common factor or do slide and divide. Well, I hope you agree with me that I can't find a greatest common factor that goes into each one of these evenly. You kind of want to divide everything by 2, but you know that that won't work with the 5. So when the greatest common factor doesn't work, we're going to do slide and divide method, and this will always work. So let's follow these steps here. Step 1 says to multiply your first and your last term together to make a new last term. So here's my first term here. Here's my last term. I'm going to multiply those together to make a new last term. So this is a positive 2 times a positive 2. That's equal to a positive 4. And then I'm going to rewrite my equation. So this 2 and this 2, I literally combined them, so those 2's are gone. So I am left with x squared. There's nothing in front of this x squared anymore. Minus 5x, because nothing happened to that minus 5x, plus 4. I'm replacing it with the numbers after I combined them. I got 4. Okay? That's step 1. Step 2 says to factor your new polynomial. So now I hope you agree that I have something that I can easily factor. Since there's no number in front of here, I can factor like I usually do. I'm going to find the factors of 4 that add to negative 5. Let's see, I have 4 and 1 and 2 and 2. Hope you agree with me that there's no way I can move 2 and 2 so that I get 5. So I'm going to cross that out. And remember, I need to find which one of 4 and 1 will work. Well, my last term is positive, but my middle number is negative. So I know that I'm going to have negative 4 plus negative 1. And if you're not comfortable picking their options yet, remember to list them all out like we talked about on Friday. Do both of your numbers positive, both of them negative, one positive and one negative, and vice versa, and you'll be able to find your answer. But for me, I got x minus 4 and x minus 1, so both of them being negative. That's step 2. You are not done after this. You need to keep going to your other steps where you need to talk about the fact that this won't get me my original problem. If I multiply these together, it won't get me my original. So step 3. Divide your factors by the number that was in front of your original problem. Okay, well, the number that was in front of my original problem was this 2. So I'm going to divide both of my factors by this 2. Alrighty, that was step 3. I just finished that. Simplify the fraction in step 4. Simplify your fraction. You must simplify first or you are going to get the wrong answers. You must simplify. So for example, what I mean, negative 4 divided by 2 simplifies to be negative 2. So x minus 2, I'm going to rewrite that because I simplified. And then negative 1 divided by 2 does not simplify to anything. That doesn't simplify any further. If the fraction was able to simplify, pretend it was x minus 2 over 4. This should be a 2. If you could, you'd want to simplify first before you did anything else. So x minus 1/2, that would simplify too. But we'll worry about that when we get there. So I simplified, and now the end of question 4 says, if you still have a fraction, slide the number in front of the x. So I do still have a fraction. One of your fractions should disappear usually. I do still have x minus 2. This fraction is still here. I'm not going to keep it. My final answer should have no fractions, but I'm literally going to pick this 2 up and place it in front of that. So then I have 2x minus 1. And these are my factors. This will be what I can multiply together to get my original equation. Alrighty, I have 2 more examples, so make sure you keep watching the video so that you know what happens, especially video about problem B. It's a little bit different. Let me know if you have any questions.